Welcome everyone. In this video we will go over section 1.1. We define what a function is. So a function is a correspondence between two sets where to each member of the first set there is assigned exactly one member of the second set. The first set is called the domain of the function, and the second set is called the range. So what is a function again is that a function comes with two sets. One set is called the domain and the other set is called the range. And every element of the domain is assigned exactly one element of the range. So basically we are pairing up the elements of the domain and the range. So a function is basically an association between the members of the domain and the range. Here's another way of thinking about it. A function is a set of ordered pairs x and y, where x is coming from the domain and y is coming from the range. So the first coordinate x is from the domain and the second coordinate y is coming from the range. Here's an example. In this example, we picked the domain set to be the set with 4 elements, 1, 3, pi, and 9. And the range set R is given by the set with the elements 6, 8, 10, and 12. Now 1 is assigned to 6, 3 is assigned to 8, pi is assigned to 10, and 9 is assigned to 12. So we are using these arrows to explicitly show what are the assignments here. And if we express this as a assignment as a set of ordered pairs, then we get 1, 6, 3, 8, pi 10, 9, 12. So this is a function, and in order to check that we indeed have a function here, we have to make sure that every element of the domain leads to exactly one element of the range, which is the case here. Find the domain and the range of the function. So here we are given a function where the function is expressed as a set of ordered pairs. So what would be the domain? Well, remember the domain, the first coordinates of the pairs are coming from the domain. So the domain would be 0, -8, half, and -3. And the second coordinates are coming from the range. So 0, 4, 1, and 4. So 0, 1, and 4, that would be the range. Now this is a function because every domain element is assigned exactly one range element. So notice that the domain element here, none of the domain elements appear twice. None of the first coordinates are the, so if I guess the best way to say it is that the first coordinates here, they don't repeat. So that's how we can check that this is indeed a function. Notice that 4 repeated here in the range, which is allowed. Now, is the following set a function? Well, this is not a function, because notice that negative 8, which is a domain element, is assigned to 4, and then it is also assigned to 0 at the same time. So because negative 8 has been assigned to two different values, so this should not be a function. Again, to be a function, going back to the definition of a function, every domain element must be assigned exactly one member of the range. So this violates that condition. Each domain element leads to exactly one range element. However, it is okay if a range element is associated with two different domain elements. So here we have a diagram where we have a correspondence that has been defined. So we want to express that correspondence as a set of ordered pairs. And so let's see so the assignments are 2 is assigned to 5, 1 is assigned to 5 and 4, and 3 is assigned to 4. So if we express that as a set of ordered pairs, we get 2 5, 1 5, 1 4, and 3 4. And we can also sketch the graph of that. That is, we can plot these ordered pairs in the xy plane. So which means that we plot the domain elements on the horizontal axis, and the range elements are plotted on the y-axis. So we have the point 2 5, which is right here. So this is 2, and then you go up by 5 units. 1 5 would be 1 along the x-axis, and then 5 units along the y-axis, and so on. And so that's the graph of this function. Well, I shouldn't say, is it a function actually? So it's not actually a function, because the domain element 1 is assigned two distinct elements. So since 1 is assigned to two distinct elements, 4 and 5, this is not a function. The relation x is equal to y squared is not a function. So what am I talking about here? Well, you're looking at, so if you look at the equation x equals to y squared, you look at the solution set, that is the set of all pairs of numbers that satisfy this equation. And is that set of pairs a function? And the answer is no, because the same number 4, so notice that 4 and 2 and 4 and negative 2, they both satisfy this equation. So they both belong to the solution set, or the graph of this equation. So since 4 is assigned to two distinct elements here, this is not going to be a function. We could also verify this in the graph of this equation. So if we look at the graph of x equals to y squared, well, that's a parabola that opens to the right, and it is not a function, for example, because the same element 4, so 1 2 3 4, is assigned to two distinct numbers 2 and negative 2 here. So to check that a given graph is a function, we can use the vertical line test. The vertical line test says that a given graph is not a function if there is a vertical line that passes through the graph more than once. So since the vertical line passes through the graph more than once, it's not a function. So to be a function, every vertical line passes through the graph at most once. Notice that this is a continuous graph. Now if I look at the equation y is equal to x squared, well, that is a function. And so again, we are talking about the solution set of this equation, the set of all pairs of numbers that satisfy this equation. And this is an equation. The graph of this equation, or the set of ordered pairs satisfying this equation, is a function because it satisfies the vertical line test. So we know that the graph of this equation is a parabola that opens upward. And if you look at this graph, you see that no vertical line can pass through this graph more than once. So this is a y is equal to x squared is a function. So in this case, the domain would be the set of all values of x for which we can compute x squared. So this for any given x value you can compute x squared. So the domain would be all real numbers. And since x squared is always non-negative, x squared cannot be negative. We see that y is always non-negative. So the range would be the set of all y values, and y has to be non-negative. So the range would be all real numbers from 0 to infinity. Okay, so if we look at this correspondence given by this set of ordered pairs, again, what's the domain and the range? Well, the domain would be given by the first coordinates, -2, -1, 0, 1, and 2, and the range would be given by -8, -1, 0, 1, and 8. So this is indeed a function because none of the first coordinates appear twice, and if we plot these points, we can plot them in the xy plane. So we plot the domain elements or the first coordinates along the x-axis. We plot the second coordinates along the y-axis. So for example, -2, -8, so you go from the origin, you go -1, -2, and then you go down by -8, so -1, -2, -3, -4, and then this here is -8. So -2, -8, that's the point. So this will be the graph of this function. One thing you can realize that all these points, they satisfy the equation y is equal to x cubed. So this is an exercise where we want to check whether a given association or a correspondence is a function or not. So we have the pairs 1, 2, 3, 4, 3, 5, and 4, 7. Unfortunately, we see that 3 is assigned to two distinct numbers, 4 and 5. Since 3 is paired with 4 and 5, it's not a function. Again, we have to check that each domain element leads to exactly one range element. So again, each domain element must lead to exactly one range element, but it's okay for one range element to be associated with 2 or 3 distinct domain elements. The blue graph here, is that a function? Well, notice that no vertical line can cross the graph more than once, so it is a function by the vertical line test. And if you look at the second graph here, which has 3 loops here, obviously there are vertical lines that pass through the graph more than once, so C is not a function. When we write y is equal to x squared, remember that this is a function, and we say that y is a function of x. We say x is an independent variable, y is a dependent variable, and we use the function notation that f of x is equal to x squared. So a lot of the times we express a function by using a formula. So when you have a function, you can think of that as an input-output process. So if you are defining a function, then you have to say for a given input, how do you calculate the output? So if the input is x, then the output is the square of that. So notice that the output y is the square of the input x here. So this is again one more way of thinking about a function. Think of it as an input-output pairs or input-output process where each input leads to exactly one output. We say this is the function with f of x is red. So this symbol here is red f of x. So for x equals to 3, what is f of 3? F of 3 would be 9, and f of negative 2 would be negative 2 squared, which is 4. Okay, for the function g of x is equal to 6x minus 3, what is g of 1? Well, so this formula tells us that if the input is x, what is the output? The output is 6 times the input minus 3. So if the input is 1, then what is the output? Well, if the input is 1, then the output would be 6 times 1 minus 3, and which is 6 minus 3, which is 3. If the input is, so what is g of negative 2? If the input is negative 2, then again, we just replace x by negative 2. And if we do that, we get 6 times negative 2 minus 3. 6 times negative 2, that's negative 12, minus 3 would be negative 15. G of half would be 6 times half minus 3. 6 times half is 3, so 3 minus 3 is 0. What would be g of a? Well, g of x is 6x minus 3. So when the input is x, the output is 6 times the input minus 3. So if the input is a, then it's 6 times the input a minus 3. So that's 6a minus 3. What is g of a plus h? Well, now the input is a plus h. So what do? Well, we multiply the input by 6. So you multiply the input a plus h by 6, and then you subtract 3. So you get 6a plus 6h minus 3. What if g of negative x? Again, the input x has to be replaced with the input negative x. So you get 6 negative x minus 3, which would be negative 6x minus 3. So again, when you have this function g of x is equal to 6x minus 3, make sure that you understand that what this formula is telling us is that if the domain element is x, then the corresponding range element is given by 6 times x minus 3. Another way of thinking about it, if the input of the function is x, then the output is 6 times the input minus 3. A similar example, so you have f of x is equal to x squared minus x, and we pretty much do what we did in the last exercise. So let me skip this slide here and go to this slide here. So what is so f of x is x squared minus x. So for a given input x, how do I calculate the output? Well, you square the input and then you subtract the input from that. So subtract the input from the square of the input. So what is f of x plus 4 then? Again, this x and this x, they have nothing to do with each other. So if the input is x plus 4, then what would be the output here? Well, if the input is x plus 4, then we square the input, and so we square the input x plus 4, and then we subtract the input. Make sure you're putting parentheses here, otherwise you're going to make a sign error. So you get x plus 4 squared minus x plus 4. Now if you expand x plus 4 squared, that is you multiply x plus 4 with x plus 4, you're going to get x squared plus 8x plus 16. And then I have minus x minus 4, so that's going to be x squared plus 7x plus 12. Okay, and if you calculate f of x, so that's x squared minus 6x, and then what is f of 4? F of 4 would be 4 squared minus 4. So if I add them, this is what I get, and if I simplify that, you get x squared minus x plus 12. Notice that that's not the same as f of x plus 4. Okay, so we're going to use the graphs to find the values of the function. So here, this graph depicts a function f, and we want to calculate f of negative 3. Well, what is f of negative 3? So we go to, along the x-axis, we go to negative 3. So here is negative 3, and then we look at the corresponding point on the graph, which is this. So notice that the height of this point is 2. So the f of negative 3 is 2. What is f of 2? So you go to 2 here. 2 is the input, and then what's the corresponding point on the graph? That's this point. What's the height? 1, 2, 3, 4, 5, and 6. So the height of this point is 6 at 2. So f of 2 would be 6. What is f of 8 here? Well, you see that you have a circle here, which is like a deleted circle, so that means that f of 8 is not defined. Notice that f of negative 3 is defined because this is a filled-in circle here. So f of negative 3 is actually 2. So what are the values of x for which f of x is 3? So I want to find I want to solve this equation, f of x is equal to 3. That is, I want to find all the inputs x for which f of x is 3. Well, the way you find it is that because I want the range value to be 3, or the output 3, along the y-axis I pick 3, and I make a horizontal line here, and the horizontal line intersects the graph at 2 points, and at these 2 points the x values are 1 and 4. So that tells me that f of 1 and f of 4 are 3. So if I'm solving the equation f of x equals to 3 for x, then x would be 1 and 4. One final slide here. We want to express the domain of the function in interval notation. So the domain means you're looking at the x values, and you see that along the x-axis the graph goes from -3 to 8, but 8 is not included because the function is undefined at 8. -3 is included, so -3 will have curly bracket, square bracket, and at 8, because 8 is not included in the domain, we put parentheses. And what's the range? Well, the range, we look at the y values, the range of y. So notice that y value goes from -3 here, but -3 is not included because 8 is not included. So you start at -3 and then you go up all the way up to 6. 6 is included, so we go from -3, we put a parenthesis at -3, and at 6 we put a square bracket. Once again, the parenthesis at -3 because notice that -3 would correspond to 8, but this circle is not filled in, or it's a deleted circle, so that means f of 8 is not defined. Okay, so this is it on section 1.1. If you have any questions, please let me know. Okay, I'll see you in the next video.